Hello everyone, so today we'll learn how to use our ESP32 board virtually. For that you have to go to Wokwi. So open your browser and search Wokwi. Then you have to go to this site, that is Wokwi. It is a simulation software where you can simulate your multiple boards virtually. Before doing the actual project, just do it virtual mode, take all the risk, do it and then try it in your physical board. That's my suggestion. Okay, now you will see here multiple boards, that is Arduino Uno, ESP32, STM32, uh, Raspberry Pi Pico. Here you will also find some of the IDE, that is VS Code and JetBrains. Okay, so I will go to here ESP32 here. After clicking there, I will find multiple projects here, that is Wi-Fi scanning, NTP clock, ESP32 HTTP server, joke machine, MicroPython. All these are the projects that are done by the users and upload it to the Wokwi platform. You can also make your project and upload it to the ESP32, Wokwi platform. Okay, now to start a new project, come here, that is start a template. Here you will find multiple boards, that is ESP32, ESP32S2, ESP32S3. So to start with the basic one, I will just click here, that is ESP32. See, this is the interface of the Wokwi simulation software. Here you will find your board, that is ESP32. On the left side, you will see a sketch file. So you can write your code here. Just inside of that, there is a diagram.json file that will give you a circuit diagram of your circuit. After completing your circuit, you can download your circuit diagram. It is a library manager. You can add some external libraries here by just clicking on this plus icon. Why to add library? Suppose you are connecting some external peripherals like DHT11 or some other sensor, you have to install some external libraries. So how to include that library? You have to click here this plus icon and to include the library in this Wokwi simulation software. Okay, now come to this simulation part. This is a green color icon, start the simulation. After writing the code, you can verify or you can run your code here virtually by clicking this icon. This is the plus icon. This plus icon is used to add multiple components like LED, DHT11s or other different peripherals. I will show you right now. Okay, so to start with the basic project, come to the sketch file. And here I am just making a simple project, that is LED blinking project. After that we will increase the level of the complexity of our project. Okay, so we have to click on this plus icon to add external devices. I want one LED, so I will click the plus icon. See, here you will find all the external devices, all the sensors, LCD, OLED module, switch, all these things. So I will need LED, so I will click here. You can also search some components here. If you don't find it, then you can search here. Suppose I want to temperature sensor, so I will search DHT. See, DHT22 is there. Okay, so I want LED, so I have taken LED, just drag and drop the thing. Okay, now to connect this LED, I need some wires. But the best part of this Wokwi platform, we don't have to search again and again wire for that. Like in Tinkercad, you have to drag and drop the wires also. But that is not in the Wokwi. So I will just click on the terminals of the LED and I will just connect it, the wire. Suppose I am connecting my anode terminal to pin number 27 of my ESP32 board. Similarly, the cathode will be connected to the ground terminal of the LED. Okay, now I am done with my circuit diagram. The anode is connected to pin number 27, the cathode is connected to the ground terminal of the Arduino. Now it's time to program this board. Okay, I am just editing this default program. You can write it by your own. Okay, see, while writing the code, all the commands are coming automatically. So this is the best part of this Wokwi. It is like other IDE where you can find your full command by just writing one or two. So you can save your time of typing. So I am just clicking here, pin mode. I am connecting my LED to pin number 27. So I will give the command 27. LED is an output device. So I will write output. Okay, so I am done with my setup function. Now come to loop function to blink the LED. Okay, for that I will give the command digital write. I have connected my LED to pin number 27. I will write 27 comma high to turn on the LED. Then after a delay of 100 millisecond, I have to turn off the LED. So again I will give the command digital write pin number 27. Now this time I have to turn off the LED, so I will give the command low. The state of the LED should be 100 seconds of turning off, so I will again give a delay of 100 millisecond. Delay of 100 millisecond. Okay, if I write 1000, then 1000 millisecond means 1 second, so the delay should be 1 second. Okay, so I am done with also my code. Now just understand this code once again. Okay, what is happening here? I am writing pin mode 27 comma output to tell the ESP32 board that in pin number 27 one output device is connected. Which output device? The LED is connected. Okay, now come to the loop function. Loop is running multiple times, that is infinite times. Okay, so I am writing digital write 27 comma high. Digital write is the command to write or to turn on something. Okay, so high is the command to turn on, low is the command to turn off. What to turn on and what to turn off. So the device that is connected to pin number 27, that we have to turn on. So I will write digital write, then I will mention the pin number, in which pin my device is connected. In pin number 27 I have connected my LED, so I will write 27 comma high and then 27 comma low after a delay of 100 milliseconds. So the state of the LED should be 100 milliseconds. It will turn on for 100 milliseconds and then it will turn off for 100 milliseconds. All these codes are written inside the loop, so it will continue its state again and again. Okay, now it's time to verify the code, so I will click here, this green icon, that is start the simulation. I have just tell you, so just click here to start the simulation. First time it will take some time, so just wait for a couple of seconds to run the code. Okay, just wait, first time it takes some time. Just wait for a couple of seconds, because it is loaded from the server side. By the way, what is server side? See, all these codes are running virtually. I have not connected any physical devices here. So something happened in the server side and that result is loaded on your screen. So you can understand that one device is there in the server side. That device is running all your ESP32 code and the result is loaded to your computer. That what it is meant by server side. So it is loaded, it will take some time to load. Just wait for a couple of seconds. If it is not working, then cancel it and again reload the thing. I have used this software multiple times. You can also use it. This is a very good software. Before trying any project, just do it virtually here, so your cost of purchasing the physical devices will reduce. Okay, see, now this LEDs start blinking. I've just opened it in another window. This is taking some time, so I've just done the same program in another window, or I can simulate it here once more. See, now the LED starts blinking. Why this message is coming? Hello ESP32, because here I have given a command serial.println hello ESP32. This is a command used to print something in your monitor. LN stands for new line, so every time I will give the command, the message should be printed in the new line. Okay, now verify. So I have given a delay of 100 milliseconds, so it is blinking very fast. If I increase the delay, that is 1000, and here also 1000. What do you mean by 1000? 1000 millisecond means 1 second. So the LED now should be turned off and turned on after an interval of 1 second. So just try that again. I am running this program. See, now the delay is more. So the LED starts blinking slowly. After an interval of every 1 second, the LED starts turning on and turning off. So this is the platform I want to show to you all, that this is a Wokwi platform where you can do your projects virtually, try it, do the coding properly, and then try it with your physical board. That's my suggestion. Okay, thank you.